name is Winston Chen, and I work on Samsung Internet and Samsung Internet for Gear VR. Over the past year, I mainly focused on WebVR for my team, but I've also done some WebAR stuff. Mainly before these type of conferences, I rush to get some WebAR stuff out as quick as I can. So I'll show you guys some of that today. So AR has been pretty huge lately. AR Core, AR Kit came out recently over the past year, and the web seems to be lagging behind a little bit, but we are working on making the web AR ready, but I won't be talking about that today. Iker, who's I think somewhere in this room, or maybe he left, he will talk about that after my talk on WebXR, which is the WebRTC standard on getting AR on the web. So today I will mostly be talking about current API specs that you can use and open source libraries that you can use to create web AR experiences pretty much right now. So these are some examples I worked on last year. These are simple AR experiences. On the right is just, well, these both use markers to track and give the ability to have a plane, like you would in ARKit and AR Core, to stick an object on it and have it anchored and give it like some type of 6 degrees of freedom movement around the scene. So recently, I think in the latest release for Samsung Internet for Gear VR, we enabled the camera feed for our VR browser so that you can access that camera and have AR. It's very interesting to see. I remember trying to take that video, and since the camera is like right this, I was trying to film it, and my marker was down here, and I kept missing it. So it was interesting to learn how a headset affects the view. But yeah, so these demos are pretty simple and straightforward. And I thought that most people look at once, say it's pretty cool, but they won't look at it again. So I decided to do something a lot more interesting this time. And I decided to go recreate one of the most popular AR applications and probably the most successful AR application, which is Pokemon Go on the web. So on the right, you can see my demo. And if you want, you can try it out on your phone. It works on Android, on Chrome, and preferably if you use our browser, Samsung Internet. So on the link that's highlighted, underlined blue, you can test it out right now. And if you want to look at the source code, it's on the second link. So basically, the web provides all the recipes you need to make Pokemon Go. You can use the Google Maps API to get your map information. And Google Maps also allows you to add your own custom markers, so you can create the Pokestops, the gym, and add the Pokemon on the map as well. And you can combine that with geolocation API to get real-time tracking, so you can move around. So if you guys are trying that right now, you should see, if you enable location services, you'll see yourself at Samsung Semiconductor in this building, and there should be a couple Pokemon that pops up around you. So I'll talk a little bit more about WebRTC, WebGL, and stuff like that, which are the two other web API and libraries that I use to create this demo. And I was kind of lazy and stressed for time, so I just went on Sketchfab, which is a huge site repository of 3D models, and I found a bunch of Pokemon models, so I downloaded that and plugged it into the demo. So WebRTC is a real-time communication JavaScript API that's available for the past couple years, and you can fetch the rear view camera and the front view camera, as well as audio. And so the beauty of this is that you can live stream that video feed that you get from your rear view camera onto the video tag on HTML. And to make it into AR, you can overlay a transparent canvas on top of the video feed, and that's how you generate your AR magic window, essentially. So my favorite library that I like to go to is Three.js. There are two other ones that are pretty popular. A-Frame, you might have heard of. And if you combine A-Frame with this JavaScript library that came out last year, AR.js, you have the ability to have AR with A-Frame as well. And then there's also Babylon.js. I don't use that much, but I've heard other companies use it at IBM and Verizon, so that's still a pretty popular library. I usually prefer Three.js because the community is better, well, personally for me. But also I like to use their device orientation controls, which how I got the motion to move around. And then they also have a bunch of object loaders, and GLTF is like the current format that everyone prefers right now, but you can load in other objects like OBJ and MTL, which I found a lot all over the web, especially on poly.google, which is also another source of 3D objects that Google has. So for the mark detection from the previous demo that I first showed you, so I used some open source library that this author ported from OpenCV. And basically, the marker detection allows you to store information. So for my demos, I store numbers that are associated with the object to display the object when that marker gets detected. And markers are pretty interesting because QR codes are also markers, and in China, a lot of people use QR codes as a way to navigate around the web because it's a lot easier for them to scan an image instead of typing in Latin characters for like a URL. And also with this library, they had a posit algorithm, which basically takes a snapshot of your image, one frame, and it figures out where the marker is. From that, it tries to compute like a 3D pose in the real world so that you can find it and do what you want with it. So you guys can try a demo if you want. So the link's right there. So if you hold your phone up, you should see, I think, the 360 camera. I think. I don't remember. But you guys are free to try, welcome to try it. So did it work for anyone? Yeah. So I can move on? All right. So here I'm going to talk about like all the libraries that you can use to do more complex, basically computer vision type of things. So Tracking.js, BRV4, and CLM Tracker allows you to do facial tracking as well. So so you can make like Snapchat if you want, and it will detect your face. Tracking.js also has other features. You can detect colors and features. And another cool thing about it, Tracking.js, is that you can train your own model to detect objects as well. And that GIF I have is straight from Tracking.js, which basically detects a video that they have on YouTube. In this case, I think it was like a Minions movie, and it's just detecting a bunch of colors. So I'll talk briefly about some future APIs that are being worked on right now. So one of them is the shape detection API. So currently, with the libraries that I talked about in the previous slide, the computation to detect these objects is pretty intensive. So a couple of Google engineers are working on this API to make facial tracking, QR markers, and text a lot easier on the web. And they promise to have it working on videos and images as well. I'm not sure when exactly this will be public, but I think if there's like a flagging enable in Chrome settings, that will enable this feature as well. And then I'll briefly talk about WebXR. It's the standard, and Iker will talk more about it, so I'll leave this all to him. And these are a bunch of extra information that might be useful for you guys. So yeah, Google Poly has a bunch of free 3D objects that you can download, add to your scene. There's this WebAR with AR Core that Iker works on. So that has AR Core mounted into Chrome, and you can play around with that. to get WebAR essentially working. And that's all I have for you guys.